over here is alpha also, right? So this angle over here is equal to 180 minus 2 alpha. So this angle over here is 2 alpha. So this angle over here will be what? 2 alpha. Okay. So now we can find stress Y2, right? We just apply the rules of the circle. Why is that there's alpha? This because over here and here is a isosceles triangle. Okay. So from here, we can calculate stress Y2, right? So stress Y2 will be equal to minus 100 minus. So if tangent 2, so let me do tangent 2 alpha is equal to y over x. X is the distance that we want. So we know y is equal to 40 divided by tangent 2 times by what? 26.565. So this would be equal to minus 100 minus by 2 times by 26.565 tangent of that. So 40 divided by is 30. So the answer is equal to minus 130 megapascal. And we are not done yet. You cannot just leave that as an answer because now, right? Yeah, it's exactly at 130. You can see that, right? So now, so we know we have to construct Mohr circle, 3D Mohr circle again. So we know that this over here is for your XY plane, and it is your in plane. Okay. Then we can have another circle. Draw. And this circle is here. Okay. And this belongs to your XZ plane, which is your out of plane. And the final circle will have a radius of 75, right? To satisfy the condition. Right? So this is the largest radius. So over here, this is for your YZ plane. And it is the out of plane. So if I were to draw the limits, okay, remember we had those limits. I just put it in just for you to see where are the limits. Not too big. So the limits is here, okay? So we know that the limits and then there's a okay, so this is the limits. So it's not going outside the limits for all the 3 circles, as you can see, right? So this is another possible solution. Okay. Now, some of you will say, Eugene, why we join minimum to point X? How we started is we join these two, right? Right, we join this line, then we start constructing. What if we do it X and Z touch together? What will happen? Okay, so I want to show you another possibility, and that possibility is wrong. Okay, it's important to show you what is right and another possibility why it's wrong. No doubt, this one you'll see all the three circles are inside the box, and it's still wrong. Okay, I'll show you again. So we draw another possibility. Okay, we draw another possibility. So now so again, okay, so this is our normal stress, then our shearing stress, okay. So again, we know that we have our 70. This is a very interesting solution. I'll show you, but it will not work. Okay, but it's interesting. And here be 40. Okay, so we know that this is point Z. We know over here this is point X. Okay, I'm going to draw the red box. I'm going to draw the red box to show the boundaries. Okay, so another possible solution, okay, is where you join X to Z. Okay, then I'm going to rotate this. Okay, I'm going to rotate this by 90 degrees. Okay, so this over here now, this over here now is now my stress A. Okay, that's where our stress A is. So we know that this is alpha. This is also equal to alpha. So now tangent alpha now. Okay, so we know now that tangent alpha is equal to what? 70. No, it's equal to 40 divided by 70. So alpha, okay, so 40 divided by 70 is tangent 29.745 degrees. right? So we need to find what is our stress A. Again, the sequence are the same, right? So it's equal to minus 70 minus by 40 tangent 29.745. So 40 times by tangent 29.745 is equal to 92.857. 8.7 megapascal. Okay, so if we were to go back into graph mode, yeah, it did not reach 100, it's about 92. Okay, then from here, you can calculate what is the stress average. Again, the same thing, right? So stress average for XY plane is equal to minus 92.857 divided by 2, because the other point is 0, right? So this is equal to 92.857 divided by 2 minus 46.429 megapascal. Okay, so now we know where the center is. So it's 46. So I'm just going to eyeball this. So 46, we're going to use green. So 46, this is 45, 46 is about here. Then from here, we can draw a straight line, right, across. Oh, I'll use a different color. Right there. So we know that over here, this is our point O, right? There is our point O. Then when we are done with this, right, we know our stress average. So now we know that this is alpha. This is also equal to alpha. And then we are aware that the angle over here is 2 alpha. This is also equal to 2 alpha. Okay. So now this is our, I call it our stress Y3, okay? Okay. So we can find our stress Y3. Is equal to minus 46.429, right? And then plus by 40 divided by tangent 2 times by 46, 2 times by 29.745. So 29.745 times 2 tangent 40 divided by, so 46, so minus 46.429 plus by, so minus 22.858 megapascal. Let me do it again. Yep, minus 22.845. So if I go back to the graph, yeah, I did not really reach 20. Okay, so now if I were to draw Mohr circle, So this thing will have to go up to a bit more than 45. Okay, so this is the Mohr circle. So this Mohr circle is very interesting, right? It touches the 3 points, point X, point Y, point Z. So this circle shows that it's possible to have one circle to represent 3D Mohr circle. Okay, so you can see, right? So this circle represents the XZ plane, which is out of plane. It will represent the XY plane, which is the in plane. And it also represents the YZ plane, which is the out of plane. Okay, so it's possible to represent a 3D element with one circle for 3D Mohr circle. This is the case. But this solution is wrong. Okay, this is not the right solution because tau max is not equal to what? 75 megapascal. Okay. In fact, tau max is equal to, so this value, the stress average, is also equal to our tau max. Tau max is 46.429 megapascal. So this is not a possible solution. Okay. And I just told you the reason why already, okay, because it did not touches the red box. Okay, all other solution, it all touches the red box. Look at this one, it also touches the red box. Is a good answer. This one, it touches the red box, but it went too big. Okay, it was not the right answer. Okay, that's all I have for you today. So this is the complete view of 3D Mohr circle. Next week we only have two hours lectures. We are going to do combined loading and Mohr circle, and we're going to talk about ductile failure. Okay, that's all. I'll still be around if you have any questions.